are going to create Arduino based door lock which is password protected. So how to get started? First of all, let's decide how our circuit will look like and which things we are going to use in our circuit. So the first thing that we are going to use in our circuit is the LCD. So we want to display something onto LCD. So the LCD would be 16 by 2 character LCD, and the next thing that we are going to use is keypad. So it means that it could be a 4 by 4 or 4 by 3 keypad to enter the password. And for the demonstration purpose, we are going to simulate this all scenario on the Proteus. So we are going to create the simulation in the Proteus, and for the output we are using LEDs for now, but you could use relays or whatever output driver you like to attach the lock to. So that's the things that we are going to use. So let's build a simulation of the Proteus first to see how it will look like. So there you go. Okay, so now our simulation is complete. So here you can see our simulation file, which is Arduino, keypad, LCD, and 2 LEDs, red and green. Green to indicate that your door is open, and red is that you entered a wrong password. Green indicates that you entered the correct password. So these are two indication LEDs, and the LCD you have, which will also tell you what the status currently, and the Arduino. So how to get started the coding? First of all, you need to include the library of liquid crystal. You can add the library by going the tool, and the sketches include library and manage libraries. So here you make sure that you have liquid crystal and keypad libraries installed. So most of the time these libraries are already installed, but if they are not, just search for them and make install these libraries. Okay, so there is a other for keypad library, and there are other bunch of libraries for the keypad. And what you need to install is this library from Mark Stanley, and this is the keypad library that we are going to use in our current project. So here if you go to the examples and scroll down for the examples of the liquid crystal, here you need to grab the hello world file. This is just to grab a little code. So this is the header file that you need to include first of all. After that, you need to create and instantiate a object of the liquid crystal. of the LCD. So there you go. Here you need to add the pin of RS. So we had attached the RS to A3 and enable to A2. So these are the two inputs that we are going to use, and A3, A2, and from next thing is D4 to D7. So we had attached over LCD D7 to pin number 8 and up to 11. So D4 is attached to the pin number 8, 9, 10 and 11. So here you go, 11, 10, 9 and 8. So now you have your LCD. Let's save the file with the Arduino Door Lock, or just LCD keypad door lock. Okay, so this is your file that we had just saved, and the next thing we need to test that our LCD is working properly, and we need to do these two things in our setup. So there you go, and let's compile the code and attach it into the Proteus and see if our LCD is working properly or not. So our code is compiled. We need to grab the hex file location or ELF file location. You can see the verbose. Here is your ELF file. So just copy this address from right. Okay, so including the location of the C drive, and put this location into the, let's select the arrow and in the program file. So this is a program file that we are going to simulate, and if you start the simulation you will see hello world on your 16:2 LCD. So here you go, it means our LCD is working properly fine. So the next thing that we are going to do is instantiate our LEDs. So let's say sharp define LED red is attached to the pin number. Let's verify that our LED red is attached to the pin number 12, pin number 13, LED pin number 13, and sharp define LED green is attached to pin number 12. So let's set up the port pin mode for the LED red as an output, and pin mode LED green as an output as well, because these LEDs are driven as negative edge triggering with the negative clock. So we need to define something here. Sharp define LED on is with the low, sharp define LED high with the, or LED off with the high. So these are two parameters that we had, the macros that we defined for our LEDs, and as soon as we configure the mode pin mode for the LEDs, we need to digital write LED red off and digital write LED green off. These are to make sure that our LEDs are off as soon as we started. So the next thing that we need to do is to set up our keypad. If you come again in your examples and you need to see hello keypad example or any that you like, just include this header file keypad.h, and we are just pasting it here right below the LCD, and here we have 4x3 keypad setup, and let's copy these two as well and write from here. Okay, so we are going to copy this here, and the pins that we attached on our row is from 0, 1, 2, 3, 4, 5 and 6. So these are the pins that we had used for the keypad, and 4 rows 3 columns. So this is the object that we initialized. Let's change this name with the M keypad, and that's how we instantiate our keypad. So these are the two objects. Let's make them together just to reference that they are objects, not the variables. Cool. So in the example, it tells that these are the function that we use to read a key. Okay, so let's copy that and paste in the loop, and let's change these to our match our object, and here you go. So instead of printing to the serial monitor, we need to print that LCD. Let's set cursor here, LCD dot set cursor to the 1 1, and come down, and let's print LCD dot print key. So let's compile the code again and verify if this code is working, so that we know that our keypad is working as well. So off is not declared in this scope. We need to verify LED off. Okay, so let's recompile the code. Now go to the simulation and see what happens. So here we have, let's press some keys. Okay, it show the hash 0 static. So it is basically rows are converted. So let's change the rows first in your code. Right here, 0 1 2 3. Let's recompile the code and see this in the simulation. Come to the simulation and see 1. Okay, so the columns are also shifted. Right, so all we need is to shift the columns as well, 4, 5 and 6. So that's how our keypad is working now, right? So let's verify that our keypad is working according to the keys. So this is a method. If you see that your keypad is have a different configuration of rows and columns, you can swap the pin numbers in your Arduino code. If you cannot change the hardware, and if still it doesn't match, you can change this 4x3 matrix, and you can put the numbers according to your keypad wiring. So if you are concerned with wiring your keypad and you are not sure how to wire them, so just don't change the hardware, just change the software, because it is easy to change the numbers here rather than tackling with the hardware. The next thing that we want to make sure is to the use cases that we are going to use. Let's talk about how the user will take the inputs. So we will create a function. Let's say that the password would be a 6-digit long. So password would be 6-digit long. It means we need a function to take 6 digits of the key presses, right? So let's create a function and name that function take keys, right? And before taking the keys, we need a global array of let's say characters, because our keys are of type characters. So we need an array of characters to hold the key presses. So user inputs. Let's call it user inputs, and here we need to define a new macro, number of keys, and let's call it 6, or call it a password length, right? Password length would be a 6-digit long. So, and initially the array will be all zeros. So that's it. Now we need an iterator value char, and okay, let's here create a char I is equal to 0 for I is equal to let's make it a do while, because it is a non-confirmative less than key values. Okay, so here let's take key press like this, and key is equal to 0. We take one key, and because we don't want to show the keys, and let's increment I plus plus here for a while. Okay, so once this all finish, let's clear the LCD. So take keys, and as soon as you enter into this function LCD dot set cursor 1 1. Cool. So take keys and replace this function, right? So, and once out of this function, let's create a 1 second delay. That's recompiled and see how this code looks for now. Here you go. It will ask for 1 2 3 4 5 and 6 digits. As soon as you enter the 6, it will clear the LCD, and it is ready to take the next 6 keys, 9 4 5 6. Cool. So the next thing, we need a function to match if this user's entered code is valid or not, and we didn't store this user input. Let's store it somewhere. I is equal to key. So now this is the way to store the keys of user input, and once user clearly inputs the keys, we will match it with the predefined password, which is also a password length type long, and the password is 1 2 let's say 5 7 and 0, and let's say again 1. Okay, so this is our password 1 2 3 4 5 6, which is 6 character long, and the user input is 0, and we need to match these two arrays. Okay, so we will create a function which will be type of bool, and it will match a password. So let's create a for loop, int I is equal to 0. For I is equal to 0, I is less than password length and I plus plus. So here we match if predefined password of I is not equal to user inputs I, then simply return false. And once this loop is finished and it did not return from the for loop, it means the password is correctly matched, so we will return true. Cool. So once we are done with this, we need to clear the so here we need to match the password, and after that we need to clear user input. All we need to do is to create a for loop of the password length, and after that we need to user inputs I is equal to 0. So that's the case. Let's once we taken the keys, let's clear input, and before clearing input, if password matched, then we will LCD dot print let's LCD dot clear LCD dot print password matched, and now we will on the LED of green, digital write LED green, LED on, and we will open the lock for a predefined, let's say 2 seconds, and then we will off the we will lock the door again, and we will let's say clear the LCD again, and LCD dot print, enter your password, and okay, so else we need to print out the indication that password do not match or the wrong password, and after that we need to make sure the password is wrong, and the LED, digital write LED green, we make sure that it is off, and digital write LED red LED on, make it on for 2 seconds. This could be your buzzer to indicate that someone attempted or someone wrong attempted, and digital write LED red, and off the buzzer or the LED again. And because we need to duplicate this code, let's grab out of this code, and there you go. So that's so good, so far so good. Let's recompile the code and see if it works as expected or it shows some error. Let's see. Okay, so let's enter the password 1 2 3 4 5 6, wrong password, red LED is on, and after some seconds it will Okay, so enter your password string is too long and it is not able to display on the screen. We will fix that later. First of all, let's verify the use case of correct password. It is 125701. 125701. 125701. So password match, green LED on, and everything will go back as expected. So the few things that remain is instead of printing the user key, we will display static sign onto the LCD, and here password. I think this message is enough, and enter, instead of enter your password, just display password, and that's it. So let's recompile the code and see if it is working as expected. Let's restart the simulation. Yes, password 1 2 3 4 5 6, and wrong password, and the correct password is, let's see what is the correct password. The correct password is 125701. 125701. 125701. So password match, right? So the last thing is to set up the new password, and for that we need to create another function which will take the keys, just like the take keys function. So let's grab this function and create a duplicate of it and reset password. We name this function, and here we need to check that if the pressed key is if key is equal to let's say hash. If user press the hash button, we will take it to reset password function, and before taking to the reset password function, we will need to clear user inputs, and we need to return. Okay, so now if user enters the password, let's say we will take it to the lcd.clear, lcd.print new password. So user need to enter the new password, and the user will enter the new password, and we need to save it into the predefined password array like this. And before leaving the screen, we need to display the message that password has been changed. lcd.print password changed, and let this message visible for 1 second and clear the LCD again. Cool. So let's compile this code and test if our password reset is working as well. So come here. Okay, let's press the hash button and it take you to the new password screen. Let enter 1 2 3 4 5 6. Password changed, and wrong password attempt, blah blah blah. It should take you to the back, and let's enter the password 1 2 3 4 5 6. This time it is password matched, right? and it backs. So that's how you change the password, enter the password, check if your password is correct or not. So that's all for today's tutorial. If you wish, you can also store this newly entered password into the EEPROM, which is a simple task, and you should attempt this by yourself. All you need to do is create another function with a for loop, and you need to save this array into an EEPROM, and in the setup you need to reload values from the EEPROM. So it is just a 6 character to write on the EEPROM, and where you need to store is you need to store in the reset function. You can put here the save password to memory or the EEPROM. So here you need to enter your EEPROM function. So that's all for today's tutorial. See you in the next one, and don't forget to subscribe if you haven't subscribed yet. So stay tuned.